Hi, this is MXUX. This is the safety recall, the NHTS recall notice that Lordstown Motors filed voluntarily and self-filed February 22, 23. Number of potentially involved, 19. These are the ones that were either in customers' hands or in use. Estimated percentage with defect, 100%. And here's just some other information. This oddly seems wrong. Hybrid, electric, light vehicle. I don't know where this is. August 23. Anyway, we're not going to worry about the vehicle information. We're going to look at this. Description of the defect. A high voltage cable assembly between the inverter and the motor may lose, so that would be on the inverter end, not on the hub motor end of the cable, may lose high voltage isolation between the bus bar and the conductive shield. May lose high voltage isolation between the bus bar and the conductive shield. Okay. Causing an unexpected reduction of power and eventual loss of power. So a high may lose a cable assembly between the inverter and the motor may lose high voltage isolation between the bus bar and the conductive shield. So the bus bar is a component of the inverter, and the conductive shield is either a part of the, I think that's a part of the cable that would connect to the bus bar. They have part numbers here, causing unexpected reduction of power and eventual loss of propulsion. So we get the cable end connecting to the inverter, and it's the inverter connection, bus bar connection that's the issue. Vehicle may experience reduction and eventual loss of propulsion without prior warning if the fault occurs. Once the vehicle is stopped, it may automatically shift into neutral. Once the vehicle is shut off, it cannot be restarted. Each of these conditions could result in an increased risk of crash, and a notification will appear on the instrument panel after this happens, indicating that the isolation fault has occurred. So, here are the components, and again, these high voltage cable assembly, front left bus bar. So this is the inverter part, I believe. The bus bar is it's like a, I'm going to try to look up this part, but just let me spitball on this. It's like a copper, it's a bar, it's a copper bar that conducts the current from the inverter, the alternating current from the inverter. It's kind of a heavy duty thing. It's kind of a big piece of copper, and this cable plugs into that, connects to that. So the front left bus bar, rear left bus bar, front right bus bar, rear right bus bar. So it was these bus bars on the inverter, which is part of the connector assembly, and this is the manufacturer is in Shenzhen. And here's a chronology. On January 20, a vehicle owned by and operated by Lordstown experienced a loss of propulsion. Subsequent similar events, so this appeared after this first model, so they all seem to fail at the same time. Subsequent similar events reported on other Lordstown controlled vehicles in the following days, and after a major snow event, and all after a major snow event in the Detroit area. So a major snow event, whatever that means. Cold, you know, ice cubes expand. Perhaps there was some expansion due to the cold. On February 1, Lordstown received a report of a customer vehicle. So these are all other vehicles in use by Lordstown in Detroit had experienced a loss of propulsion and shifted itself out of drive while at a stop before it was delivered to Lordstown for analysis. So first the internal models, then the customer model. Plant production was already on hold when these events occurred, and production remains on hold. Parts analysis was conducted by the supplier January 24 and early February. Consisted of high potentiality testing, optical imaging, 2D X-ray cross section with optical images. It looks like a CT scan 2-slice view and a CT scan 3D view. So that seems to be a pretty good analysis. Lordstown received feedback on the supplier's testing and considered the testing results, the part failure mode, and the gradual and controlled manner in which the vehicle could lose power. So, gradual and controlled manner. On February 21, 23, Lordstown decided to conduct a recall to address this issue. So, was this a temperature issue? I don't know. We're just, we have no idea, but let's not speculate on that. Anyway, there's a lot of analysis, pretty clear-cut analysis done on that. Description of remedy. Supplier has developed a new version of the part, bus bar, the BB I'm assuming is bus bar level, that will increase the high voltage isolation barrier. Okay. So, high voltage isolation barrier on the inverter. Lordstown will replace BA level bus bars with new BB level bus bars in all vehicles at no cost to owners. So again, this seems to be a part of the inverter or the connection to the inverter, the bus bar, which ultimately the plug would plug into in some form. And so it wasn't at the hub motor, it's at the inverter, and it looks like it wasn't the cable, but rather the connector itself on the inverter. The bus bar overmold holes are redesigned. That looks like the part that would hold the cable end in place. And an increased level of epoxy is applied in the redesigned parts. Interesting. So the overmold and the epoxy, so it looks like where these cables plugged in was redesigned, and the amount of epoxy that's used to hold them in place is increased. The BB level bus bar parts numbers are marked on them, okay. Only new BB level bus bars will be utilized in future production. BA level bus bars will be marked and destroyed. All vehicles inside the gate at the factory will be refit with BB level bus bars. So that is the recall, and you guys can pause this and read it. Looks like a snow event caused this to happen. Whether, with the these connections and so forth receive such a high level of testing, I can only say that this, you saw the winter testing Hightower was doing on that frozen lake, and as I said, I think once these components moved from the initial, prototype phase into mass production, I think that these perhaps the design, it sounds like the design, high voltage cable between the inverter and the motor may lose high voltage isolation between the bus bar and conductive shield. So it sounds like that tolerance was off a bit in the mass-produced version of this bus bar conductive shield, and I think this is a manufacturer, a equipment supplier manufacturer problem. I don't think this is a design problem by Lordstown Motors, and I think the testing was good on the truck, and it's good to hear that there's no hub motor connections involved, at least in this report. So this is MXUX. Guys, you can scroll through this and take a look at it. I'm going to, it is the bus bars in each inverter, and they're part of the high voltage cable assembly. And don't believe it was the cable itself, it was these plugs, and occurred during a snowstorm. Whether that has anything to do with it, I think it might. Anyway, looks like a supplier manufacturer defect, not a defect with the Endurance, with the hub motors, or with the design of the Endurance. So that's all good news. All right, this is MXUX. Thanks for watching. Good luck in the market. Okay, here you have a picture of a Endurance V1 frame. I'm going to try to make this a little bigger and see if I can show you where I think this is. Now in the back here, I think is the best way to show it. Those are, or would be, inverters. Let's see. Hi, Steve Burns. Right there, those two boxes, I believe, are the inverters for the rear hub motors. And these are the lines coming in from the battery, I guess. And then these other lines behind them are going to the wheels. So these two silver boxes would contain the bus bar, and the bus bar would be what those power leads going to the wheels plugged into. And the bus bar would basically connect those cables leading to those inverter boxes to the cables leading to the wheels. And I'm speaking out of school. I don't know if those are, I believe those are inverters. In any case, that's my interpretation, and it is that component, or that area of components, that we're talking about here. And this here is just a little bigger blow up of those units, and where those orange cables go in, those connect to connectors which are connected to a bus bar. I believe they go in, connect to the bus bar, and the bus bar connects to the connectors, and those other cables go out to the wheels. Again, it is the sockets on these units, I believe, that are connected to the bus bar for the power going out to the wheels, I believe, or it could be either way. It could be all of them that are being redesigned and the epoxy reapplied. I'm going to try to find an example of a bus bar. Perhaps not the best example of a bus bar, but this is from an electrical vehicle, and this is from EMS, is the supplier on this. But the idea being, these are actual bars of metal, of copper, I believe, and these are used to transmit these high levels of power as opposed to wires in these internal environments in these inverters. So it is a bar, and now these, they have, if you look at that one at the top, that's not a very good, let's see if maybe we can get this one here. You see that in the middle there, the terminations on that U-shaped bar. Those are the connectors. Not a good example for the Lordstown application, but it is the connectors at the end of that bus bar that are the problem with the Lordstown, in a totally different configuration, but just to give you an idea of the general form. And this is another example. This is an exploded view of an inverter, and these are the MOSFET chips. They handle high heat and high energy and convert the direct current into alternating current for the vehicle. Now, if you go down here, you've got a circuit board, then you got a cooling plate, then you got another circuit board, then you got number 12, lower heat sink. Number 14 is the lower housing. Number 16 is, if you look where that's pointed, output bus bar assembly. And you can see that that assembly hooks, well, it looks like it hooks partially onto that capacitor on the bottom. But the idea is that's a bus bar, that's a solid bar of metal, and where those little blocks, rectangles are on the top, that's the electrical connections to the inverter assembly. And then the arms sticking out with the bolt, with the little holes in it, that's where the cables would connect. Now, that's not a very good apt description of what's going on to Lordstown, but just to give you an idea of where all of this fits in to the whole thing with Lordstown. And this is yet another view of another inverter. Now that silver bar on the top there, that angled metal bar, that would be considered the bus bar. And these round sockets in the side of the box, those connect to the bus bar, connects to those, and cables connect to those sockets. And it looks like it's those sockets that have failed under temperature, under cold temperatures, at least the mass-produced sockets by this supplier. I believe this is the issue involving the redesign. Okay, guys, that's my report. I have a picture here of the Endurance. Notice the range that's listed on this electric posting. This is from 21, I believe. Could this inverter connection be part of our range change in the Endurance? That's an interesting question. Not an engineer, certainly, as you can tell by this presentation. But just a quick look at this whole system here. This is fairly accurate, I think, this picture of the Endurance. We've got inverter left front, left rear, right front, right rear. It is the connections on these inverter boxes, not the connections on the hub motors. The whole hub motor was tested in extreme conditions and specifically engineered to work, so I did not think that would be it. These, as my understanding of this goes, and do your own DD, it is the plugs that plug into these inverter boxes. The plug in the inverter box, which connects to the bus bar, a high voltage bus bar, DC bus bar, is faulty. They have redesigned the plug, and they're going to use more epoxy in seating that plug. This happened during a snowstorm. Whether the weather had anything to do with it, I don't know. curious to see if this is going to change the range. All right, guys, just closing this out. I think this has been interesting for me. I did not think that this was an error with the design of the hub motors or the connections to the hub motors. I suspected it might have been one of these connections. I think I got this fairly right. You can do your own DD. I don't think this is going to have a major effect on the stock price or the reputation of Lordstown Motors. It looks just like a move to mass production by this Chinese supplier caused a problem, which seems to have a simple solution. As I mentioned, is this part of our range issue? Is this the range issue? We don't know. But anyway, thanks for watching. We're all going to wait for the formal explanation of what's going on in 5 days, on the 7th. So until then, I guess this is my take on the problem. I hope you guys liked the presentation. I wish I could have found more detailed schematics of the actual endurance system. But anyway, this is MXUX. Good luck in the market, and thanks a lot for watching.